Hi, everyone. I hope you guys are having an awesome day so far. And it's Friday. So today, what we're going to do is I'm going to review alpha, beta, gamma. Okay, I know we kind of been working on it the last couple days, but I am going to review that real quick so that we have a really good understanding of what it all looks like so that we can be prepared to move on. Okay, so what I'm going to do is I'm going to present my screen so you can see what I'm writing. Okay, so an alpha particle. So alpha is a 4-2 helium. Okay, beta is a 0, -1 e, and gamma is a 0, 0 y. Okay, so that's alpha, beta, gamma. Now, when looking at these three, those are the three options. So what we're going to do today is what's called a decay series. Okay, the decay series is quite extensive. Okay, and I'm going to show you guys what it kind of looks like here in a second. But let's say we start with a 22286 Rn. And we say that undergoes an alpha decay. So if that undergoes alpha decay, that's 4,2 helium. What goes in the top? Well, since we have a positive 4, the opposite of positive 4, we're going to subtract 4 on both sides. So 222 minus 4 is 218. Here we have a 2, so the opposite of positive 2 is -2, so subtract 2 on both sides. 84 is the bottom, and remember the bottom is what element that tells us. So element 84 is polonium. Okay, so that's an alpha decay, but let's say that is still unstable. If that's still unstable, well, it's gonna decay again. And let's just say it undergoes a beta decay this time. Okay, in the activity, it will actually tell you what it is. All right, so if it's 0, 0 plus a blank number equals 218. So we know 218 is going to go on top, but the negative, you always have to be careful about the negative because the opposite of a negative is positive. So the bottom number is 85. Okay, so 85, our element will be astatine. And that's what a decay series looks like, okay? And then it goes under another one, and then another one, and then another one. Okay? Now, what you're going to do today is, let me see if I can find it real quick. Okay, give me a second. Chemistry. There we go. Nuclear decay. It was under something different than what I thought. Okay, so I'm going to present my screen again. There we go. So nuclear decay series. Now it looks something like this, where you're not going to have to graph it. Okay, do not graph it. You don't even have to do this part. What I'm going to do is I'm going to send you this link. Okay, I'm going to send you this page. Now, what you can do is there's different levels of difficulty. Okay, so if you're still confused, the easiest one to do is thorium. That's the only decay series card you have to do. Okay, the second, you're like, all right, I kind of want a little bit more of a challenge. The next one would be actinium. Okay. The next most difficult would be the neptunium. And if you really, really want a challenge, try the uranium. Uranium's the hardest, okay? It's the biggest challenge, okay? So what I want you to do is you can either I would suggest writing it out on a piece of paper, like I did for the previous example. Write it out on a piece of paper, take a picture of it, and you can either email me the picture or you can submit it in the Google Classroom activity. So you only have to do one of the series. You can do the uranium series, thorium series, actinium series, or neptunium series. Okay, you only have to do one of those. Okay. Now, if you have questions, let me know. Please email me. Please let me know. And the best thing about this activity is it has your final answer. You start with this. Your final answer after all those decays should be this. Same thing here. You start with this. Your final answer will be that. Super awesome. Okay. So that is all we are going to do today. So try your best. All right. Hopefully you are understanding the alpha, beta, gamma. Next week we are going to talk about fusion and fission. That's it for nuclear. All right. We'll do maybe an experiment or two. So I hope you guys have a fantastic weekend. And we will see you guys on Monday.